All right, in this video, we're going to work a few more examples of Coulomb's law using the equation to figure out the force and other things. So this is example number 4. So we have 2 ping pong balls have been painted with metallic paint and charged by contact with a Van de Graaff generator. The charge on the balls are minus 4.68 times 10 to the minus 7 coulombs and minus 3.11 times 10 to the minus 7 coulombs. Determine the force of electrical repulsion and when held a distance of 47.6 centimeters apart. So we're looking for the force. So we have Q1 is equal to minus 4.68 times 10 to the minus 7 C. That's coulombs. Q2 is equal to minus 3.11 times 10 to the minus 7 coulombs. So since these are like charges, they're repelling each other. So if we had ping pong ball 1, ping pong ball 2, the force vectors would be pointing away from each other. Then we want, so we have distance is equal to 47.6 centimeters. What we want this in meters, so we're going to divide by 100, move the decimal place over 2 to the left, so we have 0.476 meters. And then our force is what we're looking for. So we have force is equal to K is 9.0 times 10 to the 9th. This is newtons times meters squared per coulomb squared. So that's times our 4.68 times 10 to the minus 7 times 3.11 times 10 to the minus 7. It's a little squeezed in there, kind of tight. And then divided by our 0.476, and that's meters squared. So our force then is going to be equal, to 5.8 times 10 to the minus 3 newtons. Example number 5. An object with a charge of minus 5.2 times 10 to the minus 6 coulombs exerts an attractive force of 7.9 newtons on a second object location 0.453 meters away. We want to calculate the magnitude of charge on the second object. So magnitude of charge. So we're looking for Q2. Q1 is equal to 5.20 times 10 to the minus 6 coulombs. Our force is 7.98 newtons, and the distance is 0.453 meters. All right, so if we look at our equation here, we have force times distance squared over K times Q1. So let's just plug all this in. So our force is 7.98. Multiply that times our distance squared, so that's 0.453 meters. We square that. We have 9 times 10 to the 9th. That's K. And then our Q1 is 5.2 times 10 to the minus 6. Multiply all that together, do the division, and we end up with K2 equals 3.5 times 10 to the minus 5th coulombs. So the force on the second charge is 3.5 times 10 to the minus 5 coulombs. All right, example number 6. 2 different objects are given charges of plus 5.67 microcoulombs and minus 2.55 microcoulombs. What separation distance, so we're looking for the distance, will cause the force of attraction between the 2 objects to be 0.558 newtons. So 1 C is 10 to the 6 microcoulombs. Okay, so we've got the equation here. Distance is equal to the square root of K times charge Q1 times Q2 divided by force. So we have distance is equal to square root of, so K is 9.0 times 10 to the 9th. We have times, okay, so our Q1 is equal to 5.67. Now this is a microcoulomb. So 1 coulomb is 10 to the 6 microcoulombs. So that means that a microcoulomb is 10 to the minus 6 coulombs. And then Q2 is 2.55. And again, it's a microcoulomb, so it's going to be 10 to the minus 6 coulombs. Okay, so we have 5.67 times 10 to the minus 6 coulombs, and then 2.55 times 10 to the minus 6 coulombs. So all of that under the square root, multiply all those together, and divide it by the force of 0.588 newtons. We end up with distance is equal to 0.47 meters, or equals 47 centimeters. So these two objects with this charge are 47 centimeters apart, and since one is positive and one is negative, the force vectors are pointing towards each other. And they've got a decent amount of force, a half a newton force between them.